Let's go through LeetCode 911 online election. So it give two array persons in the times. So the times are sorted to represent the time which is in a sorted order. And for this time, it is strictly increasing. So there is no duplicates. And for each time, we can vote one person. So that person is in the range of person length. So that means this person can be from 0 to 5,000. So it asks at any time t what is the highest voted person. So if there is tie, return the number of person. mm, the most recent vote wins. So apparently, we need a map to count for each time there is a vote. What is every person's counts? So for this one, we can also use the array because the person is smaller equal to 5,000. So we can use the array to store the counts. And for any time t, right, we need to find the max voted person. So we have a map count everyone's votes. So for every time t, we just add one vote to um this person I, right? So at ti, we add one vote to this pi. So only this person I is possible to become the max voted person. So if it is greater or equal to the previous round max voted person, then we update this time to be the newly voted person, right? Otherwise, we are just keeping using the previous most voted person. So for Corey, let's say this T is sorted, right? So we just need to create an array called max voted person. So binary search this T to find the index. But in the binary search this T in the times, right, to find the index and get the max person. If we don't want to do binary search, we can also use a tree map, right? Use the time as a key, and just an integer, the max person as value, right? So we just use a floor key, right? We're going to use binary search, so and or whatever was tree map both will work. Um, let's use binary search way. We're going to use count person to count, right? And also we need a max person. Let's put this times outside so that we just need to for this t we just binary search these times to get its index. So we're going to have this dot times equals times, right? And have int n equals we can also have n out, right? So n this dot n equals um times dot length. So we're going to have max person equals new int n. So what we do is that for int I equals 0, I smaller than n, I plus plus, right? So we need know the person to count person I, this one increased by 1, right? So let's say if for the first one, right, I equals 0 or P2C count person I is greater equal to P2C max person I minus one, right? Then we just set max person I to be persons I, right? Else we just have max person I. Should we use a previous round, right? Max person I minus one. So we for this T, we just binary search the time, which is the last index in these times, which is smaller equal to T, right? Binary search last index in times, which has value smaller equal to T, right? So um, of course, we can there is another way, right? You can use a tree map, the key put as times, right? So for every time the max person, um, we just put a value to it so that you don't need to write binary search, just use a floor key, right? So that is another option. Let's write a binary search that will also be quick. Int start equals to 0, end equals a minus 1, right? So we'll say while start plus 1 smaller than end, int mid equals start plus end minus start divided by 2, right? So if times start is greater than t, then we need to have end equals need, right? If it equals to t, we still need to find the to the rights. And if it is smaller than t, we'll also need to find it to the right? So we'll write else start equals need. So in the end, we just will return the person, right? So that is if times n is smaller equal to t, return. This is a index. We find a max. The index is n, right? So that is max person n. Otherwise, we just return max person start. Uh, this one, let's set P2C equals new int 5001, right? Because you see, the people is small equal to 5,000. Let's take a look. Next person. So we increase this person I if next person. So this is mid, right? Mid. Let's also write a Python code for this. Let's set self dot times equals to times and self dot I equals length of persons. Self dot max person equals this one multiplied by self dot I. Actually, we don't need to use a global variable, right? Um, so we have P2C equals this one multiplied by 5001, right? So for I, P in enumerator persons, we're going to have P2C P to the plus equal to 1. And if I equals 0 or P2C P greater equal to P2C next person minus 1, right? We're going to have self dot next person I equals P set as a new person as self dot max person I equals self dot max person I minus 1, right? So for the binary search, uh, we have find the rightmost, right? The largest index, which has the times I smaller equal to t, right? So we are do the by insert right minus 1 is the largest um I equals by set right self dot times t minus 1, right? So what does this one mean? If this means if we insert t, what is the rightmost index we can insert? If it is minus 1, that will be the largest index which has this one small equal to t, right? So we just need to return self dot max person I um I think uh, it will always say that t is greater or equal to 0, right? So just return this should be enough. In enum, enumerator, enumerate max person, max person, not defined, should be self dot max person. Okay, so we'll say doing the initialization, we are just for every time, right? We add a word to a person. Um, so let's see, this is actually the linear operation for the to the to the for the initialization. It is linear, right? So, but this is n log n for binary search, and this space is also linear.